Hi everyone, welcome back to the Comptia Network Plus course, Configurations. Mistakes in the configuration of the wireless access point or wireless router or inconsistencies between the settings on the AP and the stations can also be the source of problems. The following list describes some of the main sources of configuration problems. Incorrect encryption, security type mismatch. You know that wireless networks can use encryption to secure their communications, and that different encryption flavors are used for wireless networks like wired equivalent privacy, WEP, and Wi-Fi protected access 2, WPA2, and advanced encryption standard AES. To ensure the tightest security, configure your wireless networks with the highest encryption protocol that both the WAP and the clients can support both, and make sure the AP and its clients are configured with the same type of encryption. This is why it's a good idea to disable security before troubleshooting client problems, because if the client can connect, once you've done that, you know you're dealing with a security configuration error. Incorrect overlapping or mismatched channels. Wireless networks use many different frequencies within the 2.4 GHz and 5 GHz band. And I'll bet you didn't know that these frequencies are sometimes combined to provide greater bandwidth for the user. You actually do know that this. Has anyone heard of something called a channel? Well, that's exactly what a channel is, and it's also the reason the radio stations come in better than others. They have more bandwidth because their channel has more combined frequencies. You also know what happens when the AP and the client aren't quite matching up. Have you ever hit the scan button on your car's radio and only kind of gotten a station's static written broadcast? That's because an AP radio station and the client, your car's radio, aren't quite on the same channel. Most of the time wireless networks use channel 1, 6 or 11, and because clients auto configure themselves to any channel the AP is broadcasting on, it's not usually a configuration issue unless someone has forced a client onto an incorrect channel. And also be sure not to use the same channel and APs within the same area. Overlapping channels cause your signal to noise ratio to drop because you'll get a ton of interference and signal loss. Incorrect frequency incompatibilities. So getting the channel sets the frequency or frequencies that wireless devices will use, but some devices such as an AP running 802.11gn allow you to tweak those settings and choose a specific frequency such as 2.4 or 5 GHz. As with any relationship, it works better if things are mutual. So if you do this on one device, you've got to configure the same setting on all the devices with which you want to communicate, or they won't. They'll argue, and you don't want that. Incorrect channel and frequency setting problems on a client are rare, but if you have multiple APs and they're in close proximity, you need to make sure they're on different channels frequencies to avoid potential interference problems. Wrong phrase. When a passphrase is used as an authentication method, the correct passphrase must be entered when authenticating to the AP or to the controller. When an incorrect passphrase is provided, access will be denied. This is another issue that will impair functionality. SSID mismatch. When a wireless device comes up, it scans for service set identifiers SSIDs and in its immediate area. These can be basic service set identifiers, BSSIDs, that identify any individual access point or extended service set identifiers (ESSIDs) that identify a set of APs in your own wireless LAN. You clearly want the device to find the ESSID that you're broadcasting, which isn't actually a problem. Your broadcast is closer to the neighbours, so it should be stronger unless you're in an office building or apartment complex that has lots of different APs assigned to lots of different ESSIDs because they belong to lots of different tenants in the building. This can definitely give you some grief because it's possible that your neighbour's ESSID broadcast is stronger than yours depending on where the clients are in the building. So if a user reports that they're connected to an AP but still can't access the resource they need to authenticate to the network, you should verify that they are in fact connected to your ESSID and not your neighbour's. This is very typical in an open security wireless network. You can generally just look at the information tooltip on the wireless software icon to find this out. However, you can easily solve this problem today by making the Office SSID the preferred network in the client software. Wireless standard mismatch. As you found out in chapter 2, wireless networking. Wireless networks have many standards that have evolved over time, like 802.11a, 802.11b, 802.11g and 802.11n. Standards continue to develop that make wireless networks even faster and more powerful. The catch is that some of these standards are backward compatible and others aren't. For instance, most devices you buy today can be set to 802.11a, b, g, n, which means that they can be used to communicate with other devices of all 4 standards. So make sure the standards on the AP match the standards on the client, or that they're at least backward compatible. It's either that or tell all your users to buy new cards for their machines. Be sure to understand the throughput, frequency, distance capabilities and available channels for each standard you use. Untested updates. It's really important to push updates to the APs in your wireless network, but not before you test them. Just like waiting for an update from Microsoft or Apple to become available for weeks or months before you update, you need to wait for the OS or patch updates for your AP. Then you need to test updates thoroughly on your bench before pushing them out to your live network. Distance, signal strength, power levels, location. You've got only 2 worries with this one. Your clients are either not far enough away or too far from the AP. If your AP doesn't seem to have enough power to provide a connectivity point to your clients, you can move it closer to them. Increase the distance that the AP can transmit by changing the type of antenna it uses, or use multiple APs connected to the same switch or set of switches to solve the problem. If the power level or signal is too strong and it reaches out into the parking area or further out to other buildings and businesses, place the AP as close as possible to the centre of the area it's providing service for, and don't forget to verify that you've got the latest security features in place to keep bad guys from authenticating to and using your network. So I'm going to leave here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.